Hello everyone, my name is Abdurrahman Alay and today I'm gonna speak about gas laws. So the first gas law is Boyle's law. So what's Boyle's law? Boyle's law is the pressure and the volume of a gas that are inversely proportional as one increases the other decreases and vice versa at constant mass and temperature. Boyle's law leads to the mathematical expression assuming temperature is constant. P1 equals V1 equals P2 into V2, where P1 represents the initial pressure, V1 represents the initial volume, and P2 represents the final pressure, and V2 represents the final volume. So, some key points of Boyle's law are: according to Boyle's law, an inverse relationship exists between pressure and volume. Boyle's law holds true only if the number of the molecules N and the temperature T are both constant. Boyle's law is used to predict the result of introducing a change in volume and pressure only, and only to initial state of a fixed quantity of gas. The relationship for Boyle's law can be expressed as follows. P1 into V1 equals P2 into V2, where P1 and V1 are the initial pressure and volume values, and P2 and V2 are the values of the pressure and volume of a gas after change. The second law here is Charge law. Charge law, the volume and absolute temperature K of a gas are directly proportional to an increase in temperature that leads to an increase in volume at constant mass and pressure. Charge law leads to the mathematical expression assuming pressure remains constant, V1 over T1 equals V2 over T2. And here are some key points of Charge law. At constant pressure, the volume of a given mass of an ideal gas increases or decreases by the same factor as its temperature on the absolute temperature scale. Example, gas expands as temperature increases. Now the third law we have is Gay-Lussac's law. The pressure and absolute temperature K of a gas are directly proportional. As temperature rises, so does the pressure at constant mass and volume. Gay-Lussac's law leads to the mathematical expression assuming volume remains constant, P1 over T1 equals P2 over T2. Now we move on to the combined gas law. The combined gas law expresses the relationship between the pressure, volume, and temperature of a fixed amount of gas. P1 into V1 over T1 equals P2 into V2 over T2. So one key point of the combined gas law is, by combining Boyle's and Charge and Gay-Lussac's law, the following equation is derived from P1 into V1 over T1, which equals P2 V2 into V2 over T2. And now we move on to Avogadro's law. Avogadro's law states that at the same temperature and pressure equals the volume of different gases that contain an equal number of particles. The number of molecules or atoms in a specific volume of ideal gas is independent of size or the gas molar mass. Avogadro's law is stated mathematically as follows: V over N equals K, where V is the volume of the gas and N is the number of moles of the gas, and K is a proportionality constant. So one key term of Avogadro's law is, under the same temperature and pressure conditions, equal volumes of all gases contain the same number of particles, also referred to as Avogadro's hypothesis or Avogadro's principle. And lastly, we move on to the ideal gas law. The ideal gas law states that the pressure, temperature, and volume of gas are related to each other, which is PV equals nRT. where P equals pressure, V equals volume, N equals number of moles, R equals proportionality constant, and T equals the temperature. And here are some key points of ideal gas law. Do not condense into a liquid at low temperatures, do not have an attractive or repulsive force between particles, is composed of particles that have no volume. And now, here is a conclusion. If the volume of a gas decreases, the pressure of the gas increases. And if the volume of the gas increases, the pressure decreases. And these results support Boyle's law. And now, this brings us to an end. Thank you everyone for your interest and attention.